You can also do probability with geometry, okay? Randomly, if you were to throw something, or I know with dartboards, or if you were to randomly select an area or a spot, you can use probability in geometry. What I like to think of is I like to take the target area, length, measurement, the target over the total. So that's kind of the idea. You're aiming in geometry, physically aiming at something sometimes, okay? So here we have a number line or a segment, okay? And it's measured 8 centimeters, 4 centimeters, 10, and then 10, okay? So kind of what we're doing here is if this was a randomly selected, if you were to randomly select a point along this line, what's the probability you would land here, 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 or here, or any combination of those items? Well, let's find the total first, okay? Again, I always like to do the total part. So let's go 8 plus 4 plus 20. Okay, and see what we get here for a total. Where'd you have the 20? The two 10s. Ew, 32. That's no fun. That's no fun at all. Our total's going to be 32, so we're going to do all these divided by 32. Round accordingly. I think 32 gives us not horrendous decimals. Okay, just round accordingly, depending what happens. So here we go. The probability that the point or whatever you're choosing, you land on AC. Well, AC is only 8 centimeters long, so I'm going to go, oh, sorry, AC goes from 8, sorry, A to C. Sorry, excuse me, take that back. A to C would be 8 and 4. I thought I started off with a simple one, so that'd be 12. There we go. 8 plus 4 is 12, so landing on AC would be 12 out of 32. So AC is like adding two groups. It's just like the green or blue marbles, okay? So 12 out of 32, let's see what Mr. Calculator says. Okay, 37.5, that's not too bad. 37.5%. Okay, C, D, going from C to D, 10. 10 out of 32. 31.25, that's not that bad of a decimal. Well, 0.25, yeah, don't worry about it. 31.25. That's not needed. There's no need to round a 0.25. That's not that bad. Not DE. Ooh, here we go. So shortcut, mental math. CD and DE have the exact same measurement, okay? So if this is the probability of landing on CD, okay, it would be the same thing here. So this is probability of landing. So not landing would be the complement of that. So here's what I would do, okay? I would do 100 minus 31.25. I have a feeling we're going to get a percentage of 68.75. Complements. Okay, or you can do this. How much is not DE? Well, not 10. So it'd be this 10 plus this 4 plus this 8. So what would that be? 22? Yeah. Hopefully that's the same thing. I hope it is. Nice. Look at that. Ooh, right on top. Okay. Percentage, decimal. Decimal doesn't work. Percentage is the nice way to write it. Okay. Percentage. Moving on. What do we got? Probability of landing on EA. Oh, trickery. Had the whole thing. Nice job. Wow, that was a tough one. Okay. What's the probability of landing on any part from start to finish? 100%. If this is the only part you're aiming for, you cannot land anywhere else. They're not just going to randomly say, oh, you're going to land out of bounds. No, don't worry about it. Okay, that's your target area. Okay. B to D. Let's see, B to D would be 14. So 14 out of 32. Take a look here. Okay, looks like it's going to be 43.75%. Okay, so that's with one-dimensional situations. Really quick, little side note, you could do the exact same thing. I'm not sure if you have room to write this down, but you're going to see questions kind of like this in Schoology here. So that works for one-dimensional geometry, but also works for two-dimensional geometry. So let's say you have yourself a rectangle, and the rectangle is, let's make it simple here, let's say it's 20 by 10, okay? What's the probability of landing on this circle right here? If this circle has a radius, oh, let's give it a radius of 3, okay? May not be to scale. Again, I'm just sketching this, okay? So what's the probability of landing in the circle? So probability landed in the circle, okay? Well, total area would be the area of a rectangle. How do you find that? 20 times 10, so that's 200. Okay. Now, how do you find the area of a circle? I believe the area of a circle is r squared times pi. Luckily, I gave you the radius. So I would say 3 squared times pi, which is 9. So 3 squared pi would be 9 pi. There we go. So that would be the probability. Now, I would go to the calculator, and I would type that out and see what I get here. So here we go. 9 pi divided by 200. Probability of landing on that circle randomly would be not very good. So 14, let's go to the tens place here. So when I say tens place, it's the tens place of the percentage. So technically, it's the third place of the decimal, with the decimal over 2 places. So I would say about 14.1%. So this guy right here, you've got a 14.1% chance, okay, of hitting that circle, okay. I've always wanted to do the probability of like skee ball, okay. That actually looks like a beanbag toss. Look at that, okay. I've always wanted to do the probability of like skee ball. You ever seen a skee ball game where they land in here, and then there's like the 10,000 points up there? That'd be really fun to do someday, but not for today. So anyway, that is geometric probability. And this video is going long, so I'll cut it short here. We'll go one more video.